thank you for the kind introduction and the chance to, oh yeah, the picture's there, to stay on the stage. So as I'm late in the day, I was worried a bit if I'm repeating just things that you already heard today, but I can say I have some new aspects for you for today. I want to talk about the combination and the power of the combination of geospatial data, and more importantly, geospatial tools and AI. So I'm representing Esri, which is a company I guess many of you are not know already. Doesn't matter, but within the branch of geospatial technology, we are a global leader with more than 10 million users and 90 out of the Fortune 100 companies using our technology. So what is our technology? It's GIS, Geoinformation Systems. So whenever you have the need to track assets, to manage assets, to visualize them in space and time, then GIS is the technology which comes in place. Today we are surrounded by billions of dots of data, and the amount of data is still growing exponentially. That's not a new thing. But for us, the good thing is that 80% of all the data have a spatial context, so they have information about the location in it. And we are using exactly this information to map them together to build a comprehensive view layer by layer, data by data, independently from the sensors or from the data types to get really comprehensive view. That's basically the approach how GIS works. And it works well not just for charts and maps, it works also for all infrastructure data, for plannings and simulations, for networks, complex networks like utility networks or public transportation things. And it becomes even more powerful in areas where we have a high density of objects, like in urban areas. Then we can combine all those information together to get real comprehensive view and real 3D living digital twins, which are the base and the data foundation for plannings and decisions of the future. So we as Esri did it for a long time. First, we used GIS just for creating paper maps. That is how it started. But over time, together with IT, GIS was evolving, and we get more and more capabilities. We get real digital, go 3D. We get capabilities to handle real-time data, and many more things. Today, we are talking about a web GIS, so we are fusing all the different tools and data just together by a web service architecture, and our customers using GIS for improving sustainability, managing natural resources like in agriculture and forestry. Or logistics companies using GIS to visualize and to monitor their global supply chains and to understand the risk within those supply chains. And in urban areas, I mentioned that we are powering citizen services, including public health, public transportation, public safety workflows with GIS to get real comprehensive situation awareness based on all the geodata that are coming together in those 3D environments. That's how GIS works. Well, how does that play together with AI? Basically, we can realize that today the most popular GPTs are not automatically spatially aware. Though they cannot really answer questions like, what's the spatial neighborhood? What's the dependency between different assets or other things? We need GIS for doing those things. And within GIS, we can use AI to make our own tools and functions more effective, more precise, to scale better with them. So with machine learning, we can use for finding trends and patterns within geospatial data. Deep learning, I'm syncing here, yes. We can use for extracting data out of satellite images, aerial images, or in the moment, the growing amount of drone images, so we can really automatically detect any objects, any ship, building, car, whatever you need, out of those images, and we are creating right GIS features in the right location out of those image data. Generative AI, for sure, we have heard that. We are using them in the same way like many other IT companies for creating LLMs, which gives us the possibility to create assistants, which is a new way of interaction with technology, with the tools within GIS. And all those things together, we are understanding as Geo AI. Is it going down? Yeah, no. Well, what is Geo AI? Geo AI is the sum of all those things I mentioned shortly, and you can see just a little summary here. We have the definition of Geo AI as the application of artificial intelligence fused by geospatial data and geospatial tools to accelerate real-world understanding of business problems and, importantly, environmental impacts and operational risks. So I brought you some examples in a short video on that. How does it look like?
AI is making GIS more powerful than ever. It helps you do things never before possible. like identify patterns at hyperspeed, make predictions more accurately, automate big data extraction, and so much more. When a major port wants to improve the supply chain flow, thousands of ship tracking routes are collected. Then AI and GIS analyze it to show bottlenecks in minutes, making it easy for decision makers to access.
Where is ship traffic slowing down?
And decide where shipping lanes could be widened and strengthen the global economy. Or when you need to maintain miles of power lines, using drone imagery capture. GIS analyst can apply pre-trained AI models to automate object detection while learning to recognize new patterns.
Where's maintenance needed?
To spot issues so an organization can take action within hours. If you want to understand how sea surface temperatures will impact an ecosystem in the future,
Which coral reefs will be the most threatened due to sea surface warming in 10 years?
it can process decades of data in minutes and show predictions. In a world with overwhelming amounts of data, GeoAI is a tool that empowers you to do what you've always done, but better, faster, and more precisely. Using AI machine and deep learning, it can analyze data on weather and soil across countless acres of land
Where should we plant this season?
and predict where crop yields will be biggest. Or evaluate numerous urban planning statistics
Where to build next?
to forecast multiple outcomes on where to build next. Now that you have the most advanced geospatial technology, the only question is, how are you going to use it?
So I think amazing capabilities that we have with AI and geospatial data together. So let's have a look to some examples more in detail. And the first one I brought to you is an event we had heard a couple talks ago here a little bit on that. That's the Ahrtal, close to my hometown, so I was personally impacted on that as well. But what was the situation? We had great geospatial content, we had great maps, current data, so everything was fine. But we weren't prepared for such an event because we had no predictions, we had no models, we had no idea what could happen in those extreme events. And that's an issue, that's a disaster where we have to learn out of it. A couple of years later, colleagues did much better during the Hurricane Milton in the US. And it's quite a much bigger event because it was more than 60 billion damage there, and more than 2 million people or households were impacted in that area. So the colleagues did an analysis. They extracted building footprints from Microsoft Planetary Computer, used high-resolution imagery, the road network information, the terrain information, and AI, deep learning models, to make an analysis. What will happen depending on the storm surge forecast? And then it was much easier in the time of the hurricane, so in the event, to disseminate also the emergency response teams, because we got daily fresh imagery, and with pre-trained deep learning models, we were able to make an analysis just in minutes against the traversability of other roads. So we could find the roads that are blocked by disruptions, collapsed buildings, just by the water, and we could really efficiently deal with those roads and with the overall situation with all the emergency response teams in a very, very large area, and a big impact on that hurricane. Another example here, Lovely city of Dresden, and we probably know the bridge, but it's not specifically Dresden, so I think we can or could have the same situation in many other locations in Germany, because often we talked about the conditions of German bridges and other infrastructure objects. But anyway, the bridge was collapsed, same situation. We had brilliant geodata, great maps, but we were unprepared because we had not really predicted, we had no models that could simulate those things. I haven't a solution for that case, but I think we should think more creative, more innovative, how we can use existing sensors, sensor data, and all the existing geospatial data, and especially the combination with AI, to be better prepared and get faster insights how things like those can happen. This is a view on ground movement data. That could be one approach on that. You can see green dots here on the map. They're representing observations that we did just out of Sentinel data. So it's Sentinel satellite data. This is available for all of us. And we used those data, not we personally, but the federal agency there, to calculate ground movement information very precisely in millimeter area. And if I'm zooming into Dresden and click on one of the dots, I get access to all the observations over time. And then I can see patterns within the data, and there probably something changed in 2020, so a long time before we had the accident. I'm not sure if this is the solution. Maybe this is not the right approach, but it's one of the approaches we have to think about. We have to be creative to combine the power of AI from today and the existing sensors and sensor data and spatial data to get better insights faster and earlier for those events. Now, I talked a lot about geo-AI, the combination of AI and geospatial analytics, but we have also the world of generative AI and the possibilities of AI assistants, and more in the future also AI agents. We created large language models behind our technology, which collected all the text information, documentations from the services, from the APIs, from all the software tools, and those LLMs can now provide the foundation to create AI assistants in any of the applications, not just out-of-the-box applications, but also custom applications, which can be created by any of our customers. We have lots of those applications. Some examples you can see here on the slide. We have assistants already in place for professional tool suggestions. So GIS has more than 1,000 tools for making analysis between data, for imagery, for radar data, terrain data, many more. So it's not easy to find the right tools, the right parameters, but assistants can help us. The GIS community loves to write code for automate processes, making analytics, but also make configurations of the maps, of visualizations and labels. And for all those code generations, we have assistants that makes the work of our GIS experts much faster, much more efficient. But I want to show you also on the right-hand side a bit more the look to the future. We are also thinking about integrations with other technologies. We are not just within one world with GIS. So we have the surrounding IT, and we have lots of customers and spatial questions from non-GIS experts. So we need the integration also for AI from other systems. And I have brought you one example for the Microsoft Teams integration we did. This is just my Teams tenant, my client, and this is able to connect to a GIS or to all the GIS data we have. And I'm asking, here on the screen only in German, but I can say what I did, but I think most of you understand German as well. I asked if we have access to geodata. The assistant said yes. I'm asking more specifically to a living atlas, which is a very large compendium of geospatial information for base maps, terrain data, radar data, much more, and also real-time data and statistics information. So that's a very powerful source of data, which is available to all of our users with a global context. And the assistant says, yes, I can use and search a living atlas. And then I'm asking specifically for statistics information out of census. Census is a powerful source for statistics and demographics data for us. It includes information for the community, or about the community on municipality level for data like age, genders, income per household, many more things. So it's very strategic for location decisions, for marketing purposes, but also for citizen services. And the assistant was able to find some data, but it's not enough. I'm going the next step, and I say, hey, give me an interactive web map. Give me not just the data, not just the answer. I want to have the data and an interaction, and the client switches immediately into a web mapping application. I'm still in Teams. It's not a GIS application, but we have the connection, and we can use the power with AI to search the right things, to create the right content, and to bring in all things together. And the blue areas here are the census data. By clicking on them, I have access to all those data in the specific regions. as I mentioned before. Imagine next steps on that. So you do not need to be a GIS expert. You have not necessarily a GIS application, but you can ask AI, and the AI can search, find, and compile the right information, write services and interactive maps for you to make further analysis on that. What are the takeaways on that for me and for us through the lens of a geospatial technology provider? We see that we need open systems. We need access to all the geospatial information that are available in Germany, in Europe, but also globally. We have to use open data. That's a brilliant initiative, but we see that many responsibilities, many agencies, organizations, companies are sitting on geospatial data that are not shared. They could. Maybe some data are not able to share, but many of them could be shared and could be accessible for many other applications, workflows, questions, AI assistance, as I shown it. And we have, that's more a topic for us as a geospatial technology company, we have to understand GIS as enterprise IT. So traditionally, GIS systems are made by GIS experts for GIS experts. They do analysis, they're handling the special data, they create great maps, and then they are just sharing the results. But today, with AI, we can use APIs, we can use all the functionality, and we can provide all of those tools to non-GIS experts. So we need a GIS as an enterprise IT system. Secured, hardened, following all the privacy principles, and many more things. That's the first thing. Open systems are important for the geospatial community, and they are the foundation for all other IT systems to really use the power of the combination of AI and geospatial technology. I have to look for the time a bit, so I think it's enough. But I can skip the next one. This is just how we do that, and that's a bit deeper insight in our technology. But we do that. We're using the right APIs. We have rich documentations on all of that. That is the foundation that AI can find the right tools, can find and use them, and can be used for creating workflows outside of GIS applications. But the other thing is, and that's the last part of my speech, digital sovereignty. Yes, geospatial are not special in that case. We have to fulfill all the requirements we need to talk about digital sovereignty. But geospatial data, by nature, maybe some special. So if you just want to have one satellite image for Germany with a ground resolution of 10 centimeters per pixel, then we are talking about 22 terabytes. It's just one image. Now we have not just one satellite. We have Landsat, Spot, Pleiad, Maxa, ISA. I don't know. I've read sometimes that we have more than 1,000 satellites which are making observations. So we have lots of different sources for good reasons. They have different resolutions, different multispectral capabilities. We need all of them, and we need to have access to all of those data. And then we are not talking about terabytes, we are talking about hundreds or thousands of petabytes for just geospatial foundational content. We need those content to train models. We need those content to have access to all of them, because it's not clear who of the different IT systems or workflows needs a specific one. So we are storing them in different locations, but it's a big amount of data. Data sovereignty. If we are talking about the global law, then we have more than 100 different regulations, maybe more than 100 or 200, I'm not sure, but definitely more than 100, like GDPR, APP, CCPA. GIS needs to deal and to fulfill the requirements of all of them, because geodata are global data. And so we are working, processing the data, storing the data in different nations all over the world. Data residency, we heard a bit of that today already. So that's the question, how can we store the right data in the right place? And clearly, it doesn't make sense to store all the data within one data center, especially in Germany or Europe. We need to separate the data, and we have to discuss what is the criticality of the data, what's the sensitivity of the data. So what data have to be stored really in our own country, or maybe in their own infrastructure, but what other geodata can just be consumed by services from other places. I think this is not an easy task, but we have to figure out how we can work with that big amount of geodata and with global context in terms of data and digital sovereignty. Interoperability, we heard a bit on that already today. So that's a part where I can say GIS is dealing for decades with. So we have lots of tools. ETL stands for extract, transform, load tools. So we have many different data types, data formats, coordinate systems. So we have all the time the need to transform data or services or protocols between the data to exchange them. So interoperability, I would say it's a check. So we have GIS tools which brings all the interoperability, including all the standards and the compliance that we need. But the big thing is the architecture. Today, we are providing GIS as SaaS. That's the cheapest way, but on the other side, it's the lowest sovereignty, for sure, if we are talking about global SaaS offerings. But we have also options to use GIS and deploy them in a public cloud, in a private cloud, or even in a sovereign cloud. And if it's necessary, also on the own infrastructure. Now, I talked a bit too long. But at the end, you can use them hybrid. So you have hybrid architectures, and you have to do the right decisions, how you want to work with the applications, with the data flow, with the data processing, and the data storage. And that's the message which is important in terms of sovereignty from our side as a technology vendor. Last slide, promise, just saying it. Takeaways on that. We have to think geospatial. I hope I could emphasize that a little bit with my examples, together with AI and together with enterprise IT. Traditionally, these are disciplines that are separated. Geo community was not necessarily the same like all the other IT communities. We have to bring them together and to have the same mindset on that. If we want to use the power of geospatial, then we need to deal with all these mass data with a big amount of geodata. And we need all the different data types, sensor types, and all I mentioned already. And we need flexibility in terms of the architecture, the APIs, the functions, the services. And we need for that a real GIS platform. That is not just a siloed GIS application. It is really a platform which brings all the APIs, all the rich documentations that external AI systems, assistants, and others can connect to them and can find the right tools and the right functions to solve problems of the customers. Now I'm over, I know, so I make it short. Say thank you and stay happy.